I have the pleasure to introduce you today to the WEkEO EOCanvas, which is a newly released tool. So it's like a month old or so really new. And its purpose is to process Copernicus data on the cloud. So in short, what is the EOCanvas? It's a very new WEkEO service for users, for everyone. It's a free service, so you only need a WEkEO account to try it out. It's a tool to process WEkEO and more data on the cloud. That means all the computational resources you need for process Earth observation data will not be done on your local machine, but will be done on our machines, on the WEkEO infrastructure. And it is a Python package. So this is not linked to, for example, the viewer or anything, but you can use it in your scripts, which you might have already set up for Earth observation processing. That is now all still a bit vague. So let's get a bit more into detail. Why should you use the EOCanvas for EO data processing? So this little image I prepared shows the kind of the common workflow when you want to process some satellite data or Earth observation data. So a user gets the data, for example, through WEkEO, through the WEkEO API. This then connects to all the Copernicus services, to all the Sentinel satellite data. Then you say which area of interest you're interested in, what time you're interested in, what products you're interested in, and what you get back is data. Then you download all the data and you have all the data on your machine. And then on your machine, can be a laptop, can be a computer, can be a server at your university, etc. You then have all the tools, you have the software you want to use, you have like the necessary processing resources, the storage space, etc. That's all on you. Now that works pretty well with 1 or 2 satellite scenes, but it can get a bit messy when you want to process large volumes of data. So what you get back might be terabytes of data. It is a high computational demand for your PC, and you have to manage multiple software installations. So if you have faced like those 3 problems in past Earth observation projects, then listen up now, then the EOCanvas might be useful for you and might be worth for you to try out. Because it tries to solve these 3 issues by process the WEkEO data without downloading, implementing commonly used software on the cloud, so you don't have to worry about software management, and process the data with the software on the cloud. So to come back to this usual Earth observation data processing workflow, using the EOCanvas, you might have realized, okay, the cloud is a bit bigger now. So the cloud is the WEkEO infrastructure. So what happens with the EOCanvas is that you make a data and workflow request to WEkEO, to us. In the background, still the WEkEO API connects to the data source, connects to the data and gets the data. But now the difference is the data is not downloaded to your local machine, but it stays on our infrastructure and is processed there using the commonly used geospatial software, GDAL, Data Tailor, Snap, etc. That always depends on the community, on the data, which is the most commonly tooled. And then the processing is done. And what you get back as a user is the result. So a really small, like a reasonably sized amount of data. I hope that was clear enough what the benefit is. And now I would directly jump into a demonstration, like actually 2 demonstrations. First, demo on like how to use the EOCanvas, like a small introduction, where we're gonna make a small subset of a huge satellite image tile. So we were going to cut out this small thing. So in the end that you don't have to download this huge thing, but can only download that small thing. And the second demo is about how to make out of satellite data, which comes not on a regular grid, how to bring that to a regular grid on the fly using the EOCanvas. So let me change my screens and directly jump into the first demo. It's a Jupyter notebook on the WEkEO Jupyter Hub. So you can access that Jupyter Hub, maybe I can quickly show this here. When you're logged in here with this icon, you can go to the Jupyter Hub. And within the Jupyter Hub, you'll find many training materials here in the public folder. And there you will also find the notebooks I'm showing here. So let's dive straight in. So the EOCanvas. It is a Python package, so you will need to have a Python environment. You will need to install that package into your environment, and then you will need to set up your credentials. These are your usual WEkEO credentials. And then it's already time to set up the processing workflow. So there are 3 necessary inputs for the EOCanvas to work as you want it to work. So the first is, of course, the data. So which data you want to process. Then the workflow. So which processes do you want to perform on the data? Do you want to make a small subset? Do you maybe want to select only one band? Do you maybe want to subtract bands from each other? And then the third thing is some configuration parameters. So what we're going to do here is we have a huge Sentinel-3 tile that is around like 600 megabytes big, but we're only interested in performing a process on this really small tile here. That is just a tiny subset of the data. But at the moment, if you would directly go to WEkEO and download the data, you would have to download the huge tile. And with the EOCanvas, we now see how we can just cut out that small tile here so that we do not, that your computer is a bit eased of the storage demand. The EOCanvas, it works with the WEkEO harmonized data access. So that is, well, just the API, which you can use to get the data. You will have to make a request. This is how the request looks like. In the viewer, there are many like supporting functions to get to this request. So you can use the graphical interface to get the request. And then you get an URL, and that URL is practically a pointer to the location where the data is on the WEkEO infrastructure. So you do not download anything yet, you just get this URL. And then this example now works with the software Snap, which is a commonly used software for the Sentinel data, but we also have other software implemented as on the serverless functions. For example, if you work with UMATSAT data, the UMATSAT data tailor, and it's a flexible framework. So if there is a user request to have some other software implemented, like something maybe you really regularly use, you can just raise that request with us, maybe through the user support, and then we'll see what we can do to implement also your software as a serverless function or like on the cloud. Here with Snap, we are inputting a processing workflow using Snap that looks like a nice flow chart. We read it, we subset the data, and we write the data. That is translated to an XML file, which is now the input to the function. And then the configuration parameters, it's just saying, okay, we have to unzip the data, but that's all happening in the background, so you don't have to worry about that at all. And then we put together the process already with our 3 inputs, the data, the processing workflow, and the configuration parameters. And then we send it to the server. And now this is all happening in the background. I ran this already this morning, so we don't have to wait now. It takes approximately 3 minutes to run this process. So to make from the huge 600-700 megabyte file a small file. And then you see the result has been downloaded, and it now lies in our working directory. Okay, this is now, we can now open the data set and we'll see how it looks like. Unfortunately, I see my script broke, but that doesn't matter. We'll see another example in the next notebook. So this is a first introduction on how the EOCanvas works. And now as a second example is what you can make out of it. So the second use case I want to show you is, okay, how to make this process of bringing satellite data to an identical grid and make a data cube out of it. So that's a second workflow. Again, we have like a smaller area of interest where we want to perform a process on. This time we have 3 different Sentinel scenes. We again set our workflow, we set our data input and some configuration, and then we submit all the jobs at the same time here. So three jobs are sent to the WEkEO infrastructure, and then it's doing its processing in the background. And it takes a bit longer. These are more jobs, but it takes around 6.5 minutes to get all the data ready. So 3 scenes. And then finally, we can visualize all the data in the Xcube viewer, which you can see here. So that's a component for visualizing Earth observation data. And we can now see the time series. So here is a time step. This is another time step of the chlorophyll concentration in the Baltic Sea. And that's it for the demo. I hope it was more or less clear. It's a bit of a more advanced package, but I think it's really good use, especially when you work a lot with the satellite data or the level 2 data, and you work with a high volume of data. The last minutes I want to quickly use on giving you the next steps for you if you want to use the EOCanvas. So what can you do now? You can, of course, try it out. Just go to the WEkEO Jupyter Hub, search for the notebooks, and then give it a try. I have added here all the resources, the example notebooks, the Python package documentation, and also the GitHub repository. It's a very new service, so there might be a little hiccup here and there. If you have any feedback or any questions, don't hesitate to contact us, contact the WEkEO user support. They will then answer your question or forward the questions to the developers of the package or to me. And yeah, then I invite you to give it a go. If you have like any specific use case in mind that require more resources, more quota, any other software than the software we have available at the moment, it's a really flexible framework. And of course, we do our best to support your Earth observation project. So you can contact, if you have like something specific in mind, you can contact again the WEkEO user support or also me directly. At that email address, and larger projects using the EOCanvas can also be realized as part of the Copernicus Innovation Lab, which is kind of a framework offering you the computational resources for projects that go beyond, okay, prototyping or demonstrator projects. So check out that link. Maybe that is the right thing for you. And it was, yeah, a pleasure to show you the EOCanvas, and now open to answer all your questions. Thank you.
Thanks a lot, Annalena, for your presentation. So we have a few questions for you, of course. So we are going to jump in for the Q&A for the EOCanvas. So a bit of a delay. Okay, so the first question is, so the files we downloaded from the cloud are in the format of Open DataCube. There is several questions on DataCube, so we are going to do.
So the format of the files of the download, you can choose yourself. I have chosen to download NetCDF files, but as we work with Earth observation data, they usually have the right dimensions, like the time dimension, latitude and longitude dimension, to then directly convert them, for example, to an X array. So it's compatible with tools such as the Xcube viewer. And there's also the option, as for example in Snap, to export or to download data as in ZAR format.
Okay, thanks. Okay, so this question still on DataCube. Can you download the process data, e.g. the DataCube you showed, and if yes, in what format? Kind of what you said.
Yeah, so the download that happens when you make a workflow or make a request. So you make a request on a satellite scene, and then that small part is then downloaded. So the file in a DataCube compatible format is downloaded. So if you now would go to this notebook and try it out, and you follow the exact same steps as I did, you will also be able to launch the process and then download the files in NetCDF in this example.
Okay. Thanks a lot. So yeah, we are going to put the link you showed for the Jupyter notebook in the InWay chat for the people. So if it should arrive in any minute, so no worries. So the last question we had on about the DataCube was this one. Can you explain what a DataCube is, please?
Yeah, DataCube, it's kind of a general concept of how data can be delivered. It's in Earth system sciences, we usually work with data on different grids and with like many dimensions. So n-dimensional data, because we have the time, we have the latitude, we have the longitude, and then we have the different variables. And DataCube is a format or a concept which kind of tries to harmonize that. So if you have data which is all on a regular grid, on a regular latitude, a regular longitude, regular time steps, then you talk about a DataCube that usually comes in formats such as ZAR or NetCDF, and can then be easily analyzed, easily visualized, etc.
Okay, thanks a lot. So very useful. So this question, next question, is Acolyte integrated? So
Acolyte, no, it's not
Acolyte.
integrated. I haven't heard about this software, but it's I will check it out. And then yeah, we will collect all the software requests, and then we'll make an assessment on which software is like most relevant for as many users. So if you, I will write down Acolyte now and check it out. And if there are other people listening in right now who say, oh yes, we definitely need Acolyte, then just write a request to the user support or to me with that, and we will collect it, and then we will make the next evolution based on the feedback we get from you.
Okay, thanks a lot. I will also put the question on the side to remember this one. Okay, so this question, next question, can we automate processes in EOCanvas to run the script daily, for example?
So automation is currently not supported as part of the EOCanvas, but you can, I mean, it's a Python package, so you could integrate a scheduler in Python directly to execute the scripts.
Okay. Okay, thanks a lot. Good to know also. One question asking if EOCanvas is similar to the Google Earth engine.
It's a bit more specialized. So if you've worked with Google Earth Engine, you can like really easily accept huge volumes of data there. You will have to be a bit more patient with EOCanvas because we still get the data from the original source. You've seen in the example, it took a couple of minutes to process one scene. However, we kind of reward your patience with the ability to really make your own workflow. So everything you could do in Snap, every atmospheric correction, any band maths, any process, like really specialized processes or specialized process you do with any other software, can be implemented in your Canvas. And there, I think it's the real strength. So to offer a cloud solution for also things which are not for example, supported by Google Earth Engine, or data sets which are not supported by Google Earth Engine.
Okay, thanks a lot for your nice response. So the next question, so about where we can find the Jupyter notebook. So the link to the Jupyter notebook has been put in the chat. So I invite you to check it, to find it. The message will be in blue, so you should find it easy. So next question, does this mainly differ from Sentinel Hub in that the data is stored in the cloud? Also, is this service free and can it be used for commercial purposes?
For Sentinel Hub, it's a similar approach. Sentinel Hub, as far as I know, stores a copy of the data somewhere on their cloud and cloud optimized formats. So Sentinel Hub might be slightly faster on the data they support. It's specialized for Sentinel-2, I think. Whereas the EOCanvas, you can really access any data file, which is also available from WEkEO, and it goes directly to the source. So you will be always having access to the most up-to-date data. And the service is free, can be used for commercial purposes, but of course there are quotas in place. And yes, you can process your data within those quotas. Currently, the quota is 3 processes per hour, but that is also subject to change depending on what feedback we get. If you want to do a larger project, I really encourage you to check out the Copernicus Innovation Lab, which I linked in my slides, because there we also will support projects with larger quotas on the EOCanvas, for example, so that could potentially really speed up larger processes.
Okay, thanks a lot for the explanation. So I'm going to mark this as answered. Just before we go to this question, everyone will have the PDF presentation of every presentation we have today. You will also have the replay, and you will have all of the links and all you need. So don't worry about it. So next question. So I had a suggestion. Where can I access code IDs as to how I could tailor the data processing stage to suit my need?
So there are some example notebooks available. You can find them in the Jupyter catalog or in the Jupyter Hub, in that section I linked. So you can get inspired there, I would say. And then I can really, if like I realize that it might be a bit hard to find that, okay, how can I start with the EOCanvas? So to really make that first step, I can recommend to just get a bit familiar with Snap, for example, because we have Snap implemented already, and see what you can do with Snap. And then, like, as a kind of reminder, everything you can do with Snap, you can also do with the EOCanvas. So if you have like a nice process you have in Snap and you want to move it to the EOCanvas, then it's usually just a small step. And if you face any problems, you can always contact the user support for help. But for the first step, if you really want to use it now, I would suggest to look into Snap and see what you can do in Snap, and then move to the EOCanvas.
Thanks a lot. Another technical question, is the CR2CC processors included in EOCanvas?
So I'm not a marine scientist, but I've heard about this processor. If I'm not mistaken, that is an additional plugin for Snap, and this plugin is included in the EOCanvas. So yes, it is.
Okay, thanks a lot. So we have time to 2 more questions, and then we will have to move on, but all of your unanswered questions will be put aside and answered in a post-event report, so don't worry. So this last question, is this, I find this tool powerful. Is it possible to have an accompaniment with you for a project of doctoral studies on the coastal zone in Guinea? I don't know if you do an accompaniment, I can say the word, but if you do tutorials or anything like that?
A tutorial specifically. So if you want to use the EOCanvas, I can recommend to maybe apply for the Copernicus Innovation Lab. And if you want to have a demonstration or a tutorial, we do training, so we would be open for that. Just yeah, drop me a message.
Okay, thanks a lot. Okay, so we will do the last question, and then we will move on. So, lots of questions coming. Is it possible to integrate this into a coastal zone monitoring platform?
Yes, I don't see a reason why not. So something I haven't mentioned because it goes into the technical details, but you can also connect, for example, object storage, so S3 buckets to the tool. So you're not so if you want to send the data somewhere to a bucket and then access or use the data like for a dashboard where you access this S3 bucket, that's possible as well. So we do have some flexibility here, and I don't see a reason why it should not work with a coastal zone monitoring.